Welcome students. So today we are going to learn another experiment by which we can confirm the particle nature of radiation. In last two videos we have learned about black body radiation and also about photoelectric effect. In this video we are going to learn about Compton effect and how Compton treated the light as a corpuscular particles, beam of corpuscular particles, and he succeeded in explaining his experiment. We are going to see that. It's a scattering of electron by X-ray. The experiment was about that. So suppose some initial photon with P momentum and energy E, which is nothing but h nu, is incident on an electron which is at rest with an energy of E0, and then the electron gets scattered and the photon also diverted in this way. With now photon has momentum P prime and energy E prime equal to h nu prime, whereas electron has the energy of EE and a momentum of PE. So that's the experiment, and this angle is nothing but theta. Okay, the angle at which photon is deflected is theta. So he considered, so if the classical physics was to be true, then this photon is very high energy. X-ray photons are very high energy. So the electron should not be able to absorb that much energy. Instead of, the electron should oscillate in the field of this photon and then emit a radiation of the same wavelength. So if the classical physics was true, then the wavelength will not change. The incident radiation wavelength and the outgoing radiation wavelength should be changed, because the electron cannot absorb any energy from that radiation, because it is very high energy radiation. But instead we see that there is a wavelength shift. So what Compton observed, that the incident wavelength was lambda and the outgoing wavelength is lambda prime. So this is always positive. He observed that this difference between incident wavelength and the outgoing wavelength is always higher than the incident wavelength. So how can we explain this? So we can explain this by using the corpuscular nature of the light. By using the corpuscular nature of the light, we can explain this. So what we will do, we will do the elastic collision of two particles. We will use that methodology, and we will do conservation of momentum and conservation of energy. So this is what we are going to, these two methods we are going to implement here. So let's first start with the momentum conservation. So initial momentum is P, and that should be equal to PE plus P prime. P is the momentum of electron and P prime is the momentum of the outgoing photon. Is the required electron, is the outgoing photon. So from here we can calculate PE, which is nothing but P minus P prime, and PE square equal to P minus P prime square, which is nothing but P square plus P prime square minus 2P into P dot, which is P prime, to P prime, so P into P dot, so 2P prime cos theta. So this angle is cos theta between these two things. This angle is cos theta. So we know P equal to hc by lambda, h nu by lambda. So if we replace that, P equal to h nu by c. So h nu by c whole square plus h nu prime by c whole square minus 2 h nu by c h nu prime by c cos theta, which is equal to, if we take h by c whole square to be common, then nu square plus nu prime square minus 2 nu prime cos theta. This is what we got as Pe square. Now electron rest energy is me c square, and electron recoiled energy is, according to relativity, Pe square c square plus me square c4. Now P square we got this, so we'll put it here. So the c square gets cancelled with this c square, so h square nu square plus nu prime square minus 2 nu prime into cos theta plus me square c4, and if we take h out, then this becomes h into nu square plus nu prime square minus 2 nu prime cos theta plus me square c4 by h square. This is what we get. Okay, so now we will use conservation of energy. So this is conservation of momentum. Now conservation of energy that we are going to use. So E plus E0 equal to EE plus E prime. So E is nothing but your h nu plus E0 is me c square plus E will put it here, h into nu square plus nu prime square minus 2 nu prime cos theta plus me square c4 by h square, and E prime is h nu prime. This is what we are going to, where we get. Now let's subtract it from here. So h, so we can just cancel the h, so nu minus nu prime plus me c square by h will be this much, nu square plus nu prime square minus 2 nu prime cos theta plus me square c4 by h square. Now we will make square of both sides, so this will become nu minus nu prime whole square plus me square c4 h square plus 2 into nu minus nu prime me c square by h, and this will be nu square plus nu prime square minus 2 nu prime cos theta plus me square c4 by h square. So this term gets cancelled, and from this term we will get nu square plus nu prime square, nu square plus nu prime square minus 2 nu prime, and plus 2 nu minus nu prime me c square by h, that will be equal to nu square plus nu prime square minus 2 nu prime cos theta. Again these two terms cancels out. We will take this term this side, so 2 into nu minus nu prime me c square by h square, me c square by h, not h square, me c square by h, that will be equal to 2 nu prime 1 minus cos theta. 2 gets cancelled, if we take nu by nu prime this side and this factor that side, then it becomes 1 by nu prime minus 1 by nu equal to h by mec square into 1 minus cos theta. So we can see there is a, so if we multiply by c by nu prime minus c by nu equal to h by mec 1 minus cos theta. This is nothing but your 1 by lambda prime minus 1 by lambda. So we can see there is a wavelength shift. So here one square is missing, and this is c by nu prime is equal to lambda prime minus lambda, not lambda 1 by lambda, because lambda nu equal to c by lambda and lambda equal to c by nu equal to c by lambda equal to c by nu. So c by nu prime is lambda prime. So you can see that this is a positive quantity. So this is nothing but 2 sine square theta by 2. So 2 sine square 2 into h by mec square sine square theta by 2. So 2. So this is the nothing but your Compton wavelength lambda c h by mec, and you can see this is a positive quantity. So lambda prime is always greater than lambda. Okay. So I hope this is clear, and we have learned about Compton effect. We will come up with the next video.